All right, so in this particular lesson, we're going to be learning how to shift parabolas, okay? So what I'd like you guys to do is write down what the parent function for all parabolas are. The parent function is f of x equals x squared. So what I'd like you to do, I'm just going to go over to Desmos, and I'm going to type in right here f of x equals x squared. That's our parent function. Okay. Now, if we want to shift this, there are some different rules for shifting functions you need to write down with me. So we're going to go over the rules and see if this makes sense. Okay. So let's say f of x is your original function. And when I say f of x, it could be any function. Like that's the original. If I said, what is f of x minus h, that means that graph will be shifted h units to the right. Okay, so we're going to focus on shifting right now. So any function, now ours is what? F of x equals x squared. But if I'm dealing with any function, if I want to shift it to the right, I just put f parentheses x minus h, and it'll go h units to the right. If I say, wow, f of x plus h, that's going to go h units to the left. Okay? So what we're going to do right now is we're going to show you how this applies with a quadratic. So x minus h is h units to the right, x plus h is h units left. This might be kind of confusing because you think, I thought positive would be like to the right, and negative would be to the left. Let me show you what I'm talking about. Okay? So right here, look what happens when I do, see, where is it? There it is. F of x equals, we do parentheses x minus 2 close parentheses squared. How I was at what? 0, 0. What am I now at? 2, 0. And I went 2 units to the right. So maybe if you guys see it as I do it like step by step. 1 unit right, 2 units right, 3 units right, 4 units right. See how it kind of keeps going? All right, just goes from here, keeps going to the right. Now if I change this negative to a plus, now you can see how it would go to the left. I'll explain. Why is this happening? If you think about it, it'll make sense. Like, what number would I have to plug in there to make this back equal to 0? -2. So we're at a what? We're at a -2, 0. Okay? So, in review, if that says x minus h, that's what? That's h units to the right. If it says x plus h, that's h units to the left. Okay, now we're going to switch things up. If I say f of x plus k, or f of x minus k, this is really easy. This is just k units up, and this is just k units down. We've got k units up, k units down. All right? Let me show you how that works. K units up, k units down. Watch this. What if I wanted to make this blue graph go up 3 units? I just put plus 3. Da, 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 right? If I want to make that sucker go down 5 units, boom, way down there. So what happened here? This graph, if I said, if you want to write this down, you could write down this function right here. What are the two things that have happened, the two things from this original function? It went to the, went to the left 2, and it went what? There we go, down 5. And there's my function. Sometimes we'll say, what's the function that makes it go left 2 and down 5? And that's what you would type in. So we're going to go over 4 problems. It's not going to be hard. 4 problems really quickly, then we'll move on to scaling and reflecting, which will be super, super easy. So quick review, what should you have in your journal? These right here. That's what you should have in your journal. Now we're going to go over here. We're going to go to the Khan Academy, take a look at it. And you can write this down with me. What are we always starting from? Y equals x squared. All right. And it says we want to do what? Down 3 and 2 units left. So I'm just going to write it. 2 units left would be x plus 2. Down 3 will be minus 3. That's going to be the answer that I type in. You can write it down. Better hurry because I'm about to type it in. That's left 2. This is right here, guys. That's left 2. That's down 3. Don't worry, I'll type it in. X plus 2. There's a little power. Whoa, gotta go, hold on. Gotta go to the outside of the parentheses. That's important. Squared, and then down what? Down 3? Minus, whoa, not cube. Square. Come on. Right there. There we go. Minus 3. X squared, x plus 2 in parentheses squared minus 3. There we go. Okay. Let's take a look at this one. We're not going to write it down. We're just going to look at it. That's x squared. That says x plus 4. What does that tell us happens? Left 4. So I'm going to go over here. We went left 4. And what does that tell me? Down 1. Down 1. All right. Sweetness. Okay, let's take a look at this. There's your original. What happened to the function? It looks like it went left how many units? 2, and it went up 1. So I'm gonna write it down. So I'm not gonna try to rush it. You can kind of see how I do it. It's not gonna be that hard. We're going from here to where? Right there. So I'm gonna write the words left 2, up 1. Now I'm gonna write my function for g of x. G of x will equal x plus 2 squared plus 1. I just shifted it. There's the left 2. There's the up 1. Hopefully you guys are seeing the pattern and how to write your function. So here we go. Parentheses. X plus 2. You always put on the outside of the parentheses. Okay. Raised to the power of 2. And then we had what? Plus 1. Plus 1. Yep. That's all you guys got to do on that. Okay. So that's shifting. We're done with that. Now we're going to go to scaling. Okay. So we're going to go to scaling. So what I'd like you guys to do is title this Scaling and Reflecting. I'm just going to do one video or cover 2 topics because these aren't going to be super, super difficult. All right, scaling and reflecting. So what I'd like you guys to understand, still, we're starting with the original function, f of x equals x squared. Now, if Samuel L. Jackson was your teacher, he would call that the mother function. All right? Okay? It is. This is called the parent function for all quadratics. If you don't get that joke, then you just haven't watched any movies whatsoever. Okay? All right. So we have the parent function here. Now, I want you guys to know how to scale stuff. So I want you guys to understand there's 2 ways, 2 things you got to be aware of. If I take an a value, just think of a as a number, and I take that a value and I multiply it to f of x, we're scaling it. We're multiplying it by a number. Now, if the a value, guys, if the a value is bigger than 1, we call that stretched vertically. Okay, and I'll explain what that looks like. So what does it mean to be stretched vertically? But if that a value is less than 1 but greater than 0, basically what am I saying? It's just a fraction, okay? It's a fraction of between 0 and 1. we're going to call that compressed vertically. You can put compressed, or you could call it a vertical shrink. Not the type that you see when you're having problems, okay? But they call it a vertical compression or a shrink. Now, it's still vertical. It's just vertically compressed or vertically shrunk. So we're going to show you guys what happens there, okay? So we're going to go over to Desmos real quick. Let's go to Desmos, and we're just going to focus on one number and one number only, okay? So look what happens if I put a 2x squared. Do you guys see how it's more narrow? 3, 4, 5, 6, 9. What happens as that number gets bigger? It gets more narrow, so we call that a vertical stretch because it's stretching vertically. It gets more narrow here. So in your journal, if you're writing this down, think of it this way. This is going to become more narrow. The bigger that number gets, the more narrow it becomes. What's the other way? Let's take a look. Now think about fractions because they're fun. Yeah, so we got what? 1/2, 1/3, 1/4, 1/5, 1/6, 1/10, 100. What happens? It gets wider and wider and wider and wider. The closer it gets to 0, the closer literally it gets to 0. Right now it looks like it's a perfectly what? Straight, right? Unless I did what? Unless I zoomed out, then eventually you would what? You'd see the parabolic curve right there. Okay? But if you zoom in super, like you can't even see it. That's why I like Desmos. So I can tell you about it and you can see what I'm telling you is the truth. Right? So what are we going to put right here for this? Call it what? Wide. So the closer it gets to 0, the wider it gets. The closer it gets to 0, the wider it gets. So that's kind of the basics. All right, that's the basics of the vertical stretch. Now there's one more other thing we need to talk about, and we didn't. Remember, it says scale and what? Scale and reflex. We need to go over one more little concept. I'll do that in orange, okay? Now, if you have, remember, the original function is f of x, but if I say what's negative f of x, that reflects that graph across the x-axis. And that's all you need to know. It just reflects it across the x-axis. So what does that mean for us? I'll show you real quick. Watch what happens if I just make it take that same right there, and I make it a negative. Has the width changed at all? No. It went from positive to negative. Positive to what is it being reflected across? X-axis. Now, look what happens. Check this out. This can be kind of cool. Now, this is the concept. So watch this. If I said x squared plus 2x plus 6. Oh, sorry. Fine, I'll put 24x. All right, zoom out. You guys see that? Now, look what happens if I say negative, 1 second, f of x. I don't know if you guys can see, it's got reflected across the x-axis. Look, y equals 0. That's the x-axis. Do you see it's perfectly reflected? Now look what happens. I'm going to mess with the numbers. No matter what's happening, everything's being reflected across the x-axis. So that's the other part. We're going to be reflecting. Okay? All right? So how is that going to help us with our assignment? Okay. What does that matter? So right now, what I'd like you guys to do, does everybody see my original function here in blue? And then I got a pink function right there. Now, here's what I need you guys to write down for the blue function. All right, our blue function is x squared. So I need you guys to make a table with me because you're going to use this table probably more than once. If I plug in a 0 into that, what's 0 times 0? 0. What's 1 times 1? 1. What's 2 times 2? 4. 3 times 3, 9. And then 4 times 4 is 16. That's my original function, okay? Now I'm going to switch colors over here, and now I have what's called g of x, and I want to know what g of x is equal to, and they've only given me one ordered pair to look at. So let's take a look at the ordered pair I'm going to put in this little table, okay? What's the ordered pair that they've given me to look at in my graph? 4 and an 8. So what I'd like you to do is I'd like you to take the 4 and the 8 and put it right there. Now check this out. Do you see this 4 right here and this 4 right here? They perfectly match, right? This is the old y value. This is the new y value. So what is it scaled by? What I want you to do is I want you to put the new over the original, or the old if you want to, okay? What's the new y value? 8. What was the original y value? 16. Now, remember, you have to start with the number you're comparing. See how these x's are the same, but the y's are different now? So check this out. 8 over 16 reduces to 1 half. So watch this. My new function, everybody, is 1 half x squared. That's my new function, 1 half x squared. This is not the only problem that I'm doing. I'm going to do some multiple problems. Some of them will be really, really, really easy. This is kind of the harder one. You got to figure out the function that goes with it. Okay? So in review, what did I do? What did I do right over here? I saw that 4 and an 8. So the blue, guys, the blue function right here, we made the table. Okay, that's the table that's going to stay the same. What's going to be the new one for you guys? You guys got to compare the numbers. So either you're going to compare as a 1, a 2, a 3, or a 4 with whatever you have over here. Okay, so we're going to go right over here to my problem. And I'm going to type in 1 divided by 2, x. And what am I going to do with it? I'm going to square it. Okay, now we have an easy one. So let's take a look at this easy one. You guys ready? What's our blue equation? The x squared. What's going to happen when we multiply that by a negative? What do you guys think? We multiply it by a negative, it's going to go from opening up to opening down. And that 1 half, is it going to make it wide or narrow with the 1 half? Wide. So we're looking for a graph that is wider than the blue graph and opens down. Which is wider and opens down? D. Okay? So some of them it's just like common sense once you understand the rules. Okay? Okay, let's take a look at this one. The parabola y equals x squared is scaled vertically by a factor of 1/10. Well, what the heck does that mean? Very easy. We just write down 1/10 x squared and we're done. Now, if it said it reflected across the x-axis, then you would put a negative 1/10 x squared. But that's not what it asked me to do. Right now, I have students who are falling asleep because of my voice. All right. So here we go. What am I going to type in right there? Make a fraction. I'm going to type in a 1 divided by 10. Hopefully, we'll get a more difficult one, okay? 1, 10, x squared. 1/10 x squared. All right, good. Got another one. Perfect. So listen up. When you guys get one of these, I'm glad we got more than one of these, okay? When you guys get one of these, and I have to interpret this, what did I say? Everybody needs to use that original table, and I'll make the original table again. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. If you're wondering what the heck I'm doing, I'm just multiplying 1 times 1, 2 times 2, 3 times 3, 4 times 4, because our original is f of x equals x squared. Now, let's look at our new one. Ready? What's our new ordered pair? 1, 4. Put a 1 and a 4. So now, this time, I'm comparing this with this. What stays the same? The 1s stay the same. What changed? It went from a 1 to a 4. So put the new y value over the original y value. What's the new y value? Boom. Over 1. What does that mean? That gives you your a value. I guess I didn't put that last time. That's your new a value. So the equation I'm going to put here is g of x is equal to 4x squared. And I'm done. Okay. You guys can go ahead and get started. For those of you who are in my class, if you're not in my class and you're like, what the heck are you talking about? I'm just going to keep going because I'm going to do this. I'm just going to keep going and show you how easy this is. All right. So my students, you do not have to listen to me anymore. All right. Let me keep going real quick. I have a student who has a question, so I got to pause it in just a second. All right. 1 second. Let me get this thing paused. So I have a student real quick that said they want to know how to go right 8 units. Don't worry, I'm not gonna shame the student or anything like that. I want to go right in. Now what did we start with? X squared. So if I want to go right 8 units, I'm just gonna put x minus 8 squared, and I'm done. That's how you make it go right 8 units.
That's what I was asking, but it didn't say anything about going upside.
No. So you don't have to put, if it doesn't go, if there's no up, you don't put anything. Just shifted it right 8 units. Now on this one it says, ooh, that's reflected across the x-axis, and it should be more narrow because that's a 3. So I'm looking for a skinny graph opening down, skinny opening down, skinny I'm thinking C. Yep, that's it. Skinny opening down. All right. This is scaled vertically by a factor of 2/3. So if it's scaled vertically by a factor of 2/3, it'll just be y equals 2/3 x squared. And I'm done. All right, so we're going to type in y equals 2/3 x squared. 2 divided by 3, x to the power of 2. All right, ooh, this is a good one. I'm glad I got to this one because this one probably confuses more students. We've got a 2 and a 3. Okay, so I'm going to make my little table. This is for x squared, just so you know. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. Okay, I'm going to make my new graph, my new table of the pink one. And they've only given me what? One ordered pair. What ordered pair is that? A 2 and a what? 2 and a 3. So here we go. Let's look where the x's are the same. Ready? Oop, there we go. Ha ha. That says 2, 4. That says 2, 3. What's my new y value? My new y value is 3. What was my original y value? My original y value was 4. What did I just find? Found my new a value. I realize it doesn't look like an a, but you're not going to hate me unless you do. So that's my new a value. So I'm going to put my new value is 3/4 x squared, and I'm done. So I'm going to go over to my desk, type in 3/4 x squared, and call it a day because that's all I can do. 3/4 x squared. I'm sorry, I can't help myself. I got to do this one. It's going to be this one right here because it's 2 multiplied by 2, so it's got to be more narrow, and it's going to be opening up, so that's got to be it. Okay, now I got 100. Good luck. Have a wonderful day and a wonderful life.